Imagine waking up one morning to find the sky on fire, not metaphorically, but literally ablaze with streaking fireballs, each one carrying the force of nuclear weapons. Now imagine that morning was 12,800 years ago, and the people who witnessed it were our ancestors. What they saw that day would change everything. Within hours, entire continents would be engulfed in flames. Within weeks, the climate would plunge back into an ice age. And within generations, advanced civilizations that had flourished for thousands of years would vanish so completely that we're only now beginning to remember they even existed. This isn't science fiction. This is the Younger Dryas Impact Theory, and it might be the most important catastrophe you've never heard of. For decades, scientists were baffled by a geological mystery. Around 12,800 years ago, Earth was warming nicely. The last ice age was ending. Glaciers were retreating, and life was beginning to flourish across the planet. Humans and megafauna, those giant ice age animals like mammoths, saber-toothed cats, and giant ground sloths, were thriving. Then suddenly, without warning, everything changed. The temperature dropped dramatically. Glaciers that had been melting for thousands of years suddenly began advancing again, and across North America, Europe, and Asia, dozens of large animal species went extinct in what seems like an instant in geological terms. Scientists called this period the Younger Dryas, named after a small Arctic flower that suddenly appeared in European sediment layers, indicating a dramatic return to cold conditions. For years, the explanation was simple. Maybe ocean currents changed. Maybe fresh water from melting glaciers disrupted the Atlantic circulation. It was neat, it was tidy, and it was probably wrong. Then researchers started finding something strange in the geological record. In a layer of sediment dating to exactly 12,800 years ago, they discovered materials that shouldn't be there. Nanodiamonds, tiny diamonds that only form under extreme pressure and heat. Spherules, little glass beads created when rock is instantly melted and thrown into the atmosphere. Platinum and iridium at concentrations far higher than normal. Elements that are rare on Earth, but common in asteroids and comets. And perhaps most telling, a black mat of carbon-rich material spread across multiple continents. The kind of layer you'd expect from massive wildfires burning simultaneously across enormous areas. The evidence pointed to something terrifying. Earth had been hit by fragments of a disintegrating comet. Picture the scenario. A massive comet, perhaps 100 kilometers across, enters the inner solar system. As it approaches the sun, it breaks apart, creating a stream of fragments ranging from mountain-sized chunks to objects several kilometers wide. Earth, in its orbit around the sun, passes directly through this debris field. Multiple impacts occur almost simultaneously across the northern hemisphere. Some fragments explode in the atmosphere, creating airbursts more powerful than the largest nuclear weapons ever detonated. Others slam into the massive ice sheets covering North America and Europe, instantly vaporizing trillions of tons of ice. The immediate effects would have been apocalyptic. Imagine standing in North America when the first fragments hit the ice sheet. The impact energy would have been equivalent to millions of megatons of TNT. The ice sheet, 2 miles thick in places, would have been punctured like paper. Superheated steam would have blasted into the atmosphere. Shock waves would have radiated outward at supersonic speeds. And the heat, the incredible heat from the impacts and airbursts, would have ignited everything flammable across the continent. Within hours, North America would have been a continent on fire. Forests that stood for thousands of years became fuel for firestorms that raged from coast to coast. Animals that had survived the harsh ice age conditions for millennia were caught in an inferno from which there was no escape. The large megafauna, those impressive mammoths and giant sloths, were too big and too slow to outrun the flames. Their extinction wasn't gradual. It was sudden and catastrophic. But the immediate destruction was just the beginning. The impacts threw trillions of tons of material into the atmosphere. Dust, ash, water vapor, and debris created a thick blanket around the planet, blocking out the sun. Temperatures plummeted. The brief warming trend that had been melting the glaciers reversed almost overnight. Earth was thrust back into ice age conditions, a phenomenon that would last for more than 1,000 years. Now here's where the story becomes even more intriguing and more controversial. Some researchers believe that advanced human civilizations existed before this catastrophe. Not advanced in the sense of having computers and cars, but advanced in ways we're only beginning to appreciate. Sophisticated astronomical knowledge, impressive architectural abilities, complex societies with long-distance trade networks, and the Younger Dryas impact wiped them out. Consider the evidence that keeps emerging. Göbekli Tepe in Turkey, dated to around 11,000 years ago, features massive stone pillars carved with intricate designs and arranged with apparent astronomical alignments. The level of organization, skill, and knowledge required to build such a site suggests a society far more sophisticated than we traditionally associate with that time period. And here's the key point. Göbekli Tepe was built after the Younger Dryas event. If people could build something that impressive in the aftermath of a global catastrophe, what were they capable before it? Ancient myths from around the world tell remarkably similar stories. Floods that covered the earth, fire falling from the sky, a time when the sun disappeared and darkness covered the land. The Egyptian accounts of Tepe, the first time. The Sumerian king lists that speak of rulers before the flood. The Aboriginal Australian stories of a time when the sky fell. The Native American legends of the sky burning. Could these be cultural memories of real events, passed down through countless generations? The mainstream archaeological community remains skeptical, and for good reason. Extraordinary claims require extraordinary evidence, but the evidence keeps mounting. The impact markers in the geological record are real. The sudden extinction of dozens of megafauna species is undeniable. The dramatic climate reversal happened. The question isn't whether something catastrophic occurred 12,800 years ago. The question is how it affected human civilization. Think about what such an event would do to any human society. Coastal settlements would have been destroyed by massive flooding as the ice sheet collapsed. Inland communities would have been consumed by fire. Those who survived the initial impacts would have faced a world transformed. Food sources disappeared as animals went extinct and vegetation died. The temperature drop would have made survival incredibly difficult. Knowledge, accumulated over generations, would have been lost as elders and specialists perished. This is how civilizations disappear. Not gradually, not by slowly declining, but catastrophically. One generation possesses knowledge and skills. The next generation, struggling just to survive, loses that knowledge. Within a few generations, sophisticated societies can be reduced to scattered bands of survivors who retain only fragments of their former glory, fragments that become myths and legends. The Younger Dryas Impact Theory suggests that human history isn't a simple story of steady progress from primitive hunter-gatherers to modern civilization. Instead, it's a story of cycles, of rising and falling, of catastrophes that reset the clock of human achievement. It suggests that we might be rediscovering knowledge that was once known and lost, rebuilding what was once built and destroyed. Today, as we map ancient sites with satellite imagery and ground-penetrating radar, as we explore the ocean floor with submersibles and sonar, we keep finding anomalies, structures that seem too old, too sophisticated, too carefully placed to fit our current understanding of human history. And each discovery makes the Younger Dryas Impact Theory seem a little less radical and a little more plausible. The theory reminds us of something important. We live on a dynamic planet in a dangerous cosmic neighborhood. The impact that may have occurred 12,800 years ago wasn't the first and won't be the last. The difference is that our ancestors had no warning and no way to prepare. We do. Understanding what happened during the Younger Dryas isn't just about solving an ancient mystery. It's about recognizing the real threats that still exist and ensuring that if such an event occurs again, our civilization doesn't vanish like those that may have come before us. The evidence is there, carved into rock layers, preserved in sediment, encoded in ancient myths, and possibly buried beneath our feet, waiting to be discovered. The Younger Dryas Impact Theory is still debated, still investigated, still controversial. But one thing is certain. 12,800 years ago, something extraordinary and terrible happened to our planet and to the people living on it. And the more we learn about that event, the more we learn about ourselves and the fragile thread by which all civilizations hang.